Hi everybody, Mr. Boyle here. Today's lesson is going to talk a little bit about, I'm sure you've seen this on Facebook or Instagram, and the question is, how many triangles do you see? Now, at first glance, it seems pretty easy, but then you realize that there are multiple triangles in this picture that are overlapping each other. And that's what today's lesson is about, how to deal with similar triangles that are overlapping each other. I'm Mr. Boyle. Are you ready? Hi everybody, Mr. Boyle here. Welcome to week 2 of remote learning. Today we're going to keep talking about similar triangles, but we are going to show you a different scenario that can come up. You can tell from the intro video today, we're talking about triangles that overlap each other. Right now, up on the board, all you see is one triangle. So what I'm going to do is very quickly, I'm just going to draw a line segment in here. So as you can see, the line segment I drew is parallel to the third side here, and it creates two triangles. We have little triangle BRT and we have big triangle BFK. Question first is, are they similar to each other? Now remember from last week, I said one way to check to see if triangles are similar is to check if the angles are congruent. Well, from what we've learned in the past, I know that angle R and angle F are congruent because those are corresponding angles. I know angle T and angle K are congruent because they're also corresponding angles. So we already have two pairs of angles congruent. Where's the third pair? Well, it's all the way at the top. We have angle B congruent to angle B. That's reflexive property. So we do have similar triangles, so I'm going to give you a similarity statement here. We have triangle BRT is similar to triangle BFK. Bottom line, there you go. Now remember, if the triangles are similar, that means the corresponding angles are congruent. And now we're going to get to the sides. The sides are not congruent, but they're proportional to each other. So what could a typical problem look like? I'll put some givens in here. All right. So I have this problem set up here. And you can see the problem we have here is I want to know how long is line segment RF. That's where I put the X. Now, the first instinct you're going to have is going to be the wrong instinct. If you are like 90% of my students who learn this the first time, here's the proportion that you're going to set up. I'll let you pause it for a couple seconds, write out your proportion, and then you tell me if that's what you wrote. Now, here's what you probably wrote. You probably wrote something like 6 over x equals 8 over 14. I want to be clear. This is the wrong proportion. If you have this written down, if you have 8 times x and 6 times 14 like that, erase it. It's wrong. Let's talk about why. Here's the reason why. Look at line segment RF. Line segment RF is not actually a whole side of a triangle. If you look at line segment BR is a whole side of triangle BRT. Line segment FK is a whole side of the big triangle. But if you look at line segment RF, that's not actually a side of a triangle. It's a piece of a side. Which side? Well, it's actually a piece of this whole line segment BF. So we can't just say that it's going to be BR over RF, RT over FK. That's not going to work. So this problem becomes a little bit more confusing when the triangles overlap like this. And instead of setting up a proportion with the numbers, let's set up a proportion with the letters. Now, first thing is, I'm just deciding I'm going to put the little triangle on top and the big triangle on the bottom. That's what I chose. I'm going to stick with it. I'm going to put that over here just to remind myself. So let's begin now. So first of all, I need a side from the little triangle. Right away, I see that BR is a side of the little triangle. Now the question is, what line segment pairs up with line segment BR? Now remember, don't look at the picture, look at the statement. If I look at the statement, I see BR, first and second letter, and I see BF is this first and second letter. So I'm going to say that BR goes with BF. And now I need another side of the proportion. Go back to the little triangle. The only other side of the little triangle that we know is line segment RT. So I'm going to go with line segment RT. Now, what line segment goes with RT? Once again, use the statement. If I look, line segment RT goes with line segment FK, second and third letter. And now we have our starting proportion. Now what we're going to do is substitute in what we know about those line segments. And here we go. The first thing is going to be, now give me a second to set this up. So let's see. BR. I can see right there, BR is 6 centimeters long. BF, I'll tell you what, let's come back to line segment BF. Line segment RT, I can clearly see is 8. And line segment FK, I can clearly see is 14. Now let's go back to BF. How long is line segment BF? Well, BF is actually from here all the way down to here. Now, once again, here comes a common mistake. What I'm going to write is wrong. Everybody wants to write 6x. That is wrong. 6x means 6 times x. It's not right. If this was 6 centimeters and this was, let's say, 5 centimeters, how long would the whole thing be? It wouldn't be 6 times 5. It would be 6 plus 5. So you don't multiply these two pieces together. You're going to add them. So if BR is 6 and RF is x, how long is BF? You should have guessed by now. It is 6 plus x. And we have our starting proportion. Now let's go ahead and try to solve that proportion, and this should go pretty fast. So I've cleared some stuff out of the way. Let's go ahead and do what we always do, cross multiply. After you cross multiply, this is what you should be looking at. 8 times 6 plus x, 6 times 14. Now let's have the algebra kick in. Do a little distributive property over here, multiply over there. Subtract 48 from both sides. Divide both sides by 8, and you get 4.5 for x. Let's look over. X represents line segment RF, so I'm going to put as a final answer that RF equals 4.5 centimeters. This might be a video you want to re-watch a couple times until it starts to make sense. There's going to be a worksheet on problems that look just like this now. This will be called worksheet number 3. It will be in Google Classroom. Monday through Friday, you are free to come visit me during my office hours using Google Meet, and we can talk about problems like this in case you're not following along. That's all for today. I'm Mr. Boyle. Have a good day.